In this video, we're going to look a little bit more at reflections. So this first example says, graph the image of V, 10, and 1 after a reflection over the x-axis. So this is our x-axis. So this is essentially kind of the mirror where we're flipping it. So right now, V is 1 above 10. So I hope you realize that we're just going to flip it. We have to make sure it's 1 away, so we're going to go 1 away over here. So I'm going to take my little pencil, and the reflection would be right there. Notice that's the same distance from the x-axis as this side. That's what we want. And obviously it's in the same aligned with it. It's like it's looking in a mirror. In this example, it's the same concept, but now we're looking at a square. Graph the image of square PQRS after a reflection over the line x equals -3. By the way, it's called x equals -3 because it's a straight line that goes through x at -3. The x-axis obviously being here. So, same as we did before. Just got to make sure we have, so it's 1, 2, 3, 4, 5. P is 5 away from this line. So we're going to go 1, 2, 3, 4, 5 on this side. So you can see now that I've reflected all of the points as according to this line of reflection. So P is now 5 away on this side. So, and I find that easier because sometimes kids will get confused. They're like, oh, well, this one's a 2, so it should be -2. No, you're reflecting according to this line of reflection. The other thing, be careful. Notice Q is still further away from the line of reflection. Some kids will get confused and put P here and Q here. No, Q is further away, just like when you look in a mirror. S was 5 away, so it's 5 away. R was 7 away, so it's 7 away. We end up with a square over there. This example looks a bit confusing to kids because the line of reflection is on a diagonal, but it's exactly the same concept, and some might even say it's a little easier. Graph the image of n at -8 and -1 after a reflection over the line of x equals y. This is called x equals y because when x is 1, y is 1. X is 2, y is 2. But anyhow, so right now, n is at -8 and -1. So we're just going to make sure it's at -1, -8. So I take my dot, put it right there, because it's still down, so it's 8 over this way. So we're going to make it 8 down. And then, I know it's a little bit of a weird concept, but I hope you can see that that is the mirror reflection right here. Instead of having it at -8 and -1, I have it at -1 and -8. In these last two examples, we're doing the same thing, but again, it just wants us to think a little bit more about the coordinates. So the point J, 4 and 1, is reflected over the x-axis. What are the coordinates of the resulting point J1? So J1 is obviously going to be about, let's see here, right? It's 1 above, so it's going to be 1 below there. And let's just write in the coordinates. It's over 1, 2, 3, 4, and it's down -1. Whereas before, J was 4 and 1, J1 is 4 and -1. In this example, we're doing the same thing, but it's just with a shape. So write the coordinates of the vertices after a reflection over the line y equals 2. So there's 2y2. They've got their line of reflection there. So obviously for this one, V1 is going to actually be right in the exact same spot because it's right on that line of reflection right there. But I'm going to have to count for the other ones. U, so we're going to have U1 is going to be, it's 1, 2 away, so it's going to be 1, 2 up here. W is 2 down, so it's going to be 1, 2 up there. And T is 1, 2, 3, 4, 5, 6 down. So it's going to be 1, 2, 3, 4, 5, 6 up. So now I've gone ahead and filled that all in, and I've tried to sort of recreate the shape. Again, your shape should look exactly the same. Otherwise, you've done something wrong. You'll also notice that, and I can see it mostly down here, first of all, V is exactly the same coordinates as V1. W1 and U1 have the same X value, same as, T1, because it's just moved up. It hasn't moved over. So it's just the Y value that has changed. Yeah, and I think that's pretty self-explanatory. I've just counted up. So that's it for this section, and good luck on your practice tasks.